Okay. Hi, everybody. My name is Jason. I'm Technical Service Manager here with Leary Company. Today, I'm going to give you some training and a tutorial on our Monet user interface, basically our gluing and detection software. Okay. So from the home screen, you have access to the system menu, and the system menu can be accessed with one of two passwords, either the manager level password, which you guys will have access to, and your password, we were told, is going to be 1028. So your access to the system menu gives you limited access to the various system setup options, but the key options that you do have access to is if you ever wanted to change the language of the system, you have this global tab here. And within the global tab, the last setting listed on the global tab is the language, and you have a drop-down menu where you can adjust the language to whatever language is suitable, depending on where the machine is shipping. You also have whether or not you want to use metric units, whether you guys want to use millimeters or inches. It'll also change the speed reference display from meters to minute to feet per minute. So it looked like you guys were originally set up on metric units. You can change your glue pressure units from PSI to bar. So we normally use PSI here, but I know everybody else in the world pretty much uses bar. The month, date, year format can be changed. We don't display our date quite the same as everybody else. So those are some of the things that are important within the global menu that allows you to change kind of the language and some of the other kind of global features, how the date's displayed, and whether or not you want to use metric units versus standard or imperial units. Some of the other things you have access to at the manager level access is the shift tab. So on the shift tab, we have the ability to program shift start times. So if the end user is interested in collecting data to that USB key or those production information, we can have them pick the frequency that they actually would like to have that report printed to a USB key, whether it's at the end of each day, job, or shift. So depending on how frequently they want that report printed, and if they do want to print per shift, it's important that we actually have the actual shift times. What's the total number of shifts and what their shift start times are. On this menu, you can also correct the time. So if the time display was incorrect for some reason, or if everybody changed their clocks ahead an hour or behind an hour, and the Leary system was off, you can go into the shift tab and correct the time. Probably not a lot else. This job totals display could be beneficial. Job totals display tells the system whether the main counts on the home screen, the feed and trombone count, should reset automatically at the start of each shift, or if they should just continue counting until they actually physically change the job name. So if job totals display is turned on, the system will continue counting indefinitely until you change the job. If you leave the job totals display off, it'll automatically reset back to 0 at the start of each shift time that you got set above here. I'll show you where that's at, though. I'm gonna go ahead and show you just a couple more things with the manager access that might be beneficial for you. The GRU set points. So on the pressure graph screen, which we did not get to yet, you can actually program how many different set points throughout your speed range you'd like to have available. So how many different pressure setting points you'd like to have available on your pressure graph. So yours, this is the file from your last install. So you guys seem to be okay with having 3 set points. And we can also program what the purge pressure is for your tank number 1, which what we call GRU1. So tank number 1 purge pressure, and then GRU2 would be your tank number 2 purge pressure. So you got 2 pressure regulation screens. You got 3 set points set up on each pressure regulation screen, and your purging pressure is set to 20 psi for both of them as well. So that's probably what's about the most beneficial there. Yeah, I don't think you guys would find too much beneficial here. There's no batch count, nope. If you wanted to tell the system how many consecutive failures you would allow before the machine shuts down, before the Leary system performs a machine stop, you can program that right here. Consecutive rejects to machine stop. So that's another thing that might be beneficial for you. Being able to dictate how many consecutive failures the system sees before it performs a machine stop. And of course, that gives us more features, more options, and the kind of the important one here is this calibration menu. The calibration menu has a couple of key features on here that's important for the initial installation and commissioning of the system. The first one is the pulse to length ratio. So this is where we can actually adjust what our speed reading is compared to what the machine is actually the linear travel of the belt. All right. So depending on where we mount our physical encoder, our encoder wheel, whether it's on a carry belt or connected to a gear or coupled to a shaft, there's quite a few various ways that we can actually tack machine speed. But if it's not using a direct contact wheel to a carton belt or a product belt, sometimes we have to go in here and we have to adjust the pulse to length ratio. The best way to go about doing this is you guys have two encoders on your machine. I would start with just the first section of the machine. If the machine actually has some type of belt speed reference, you can reference that. Let me turn my simulator back. So the best thing I find to do is to try to match the host machine. So whatever the host machine is telling me, if the host machine tells me it's running 50 meters per minute, I can adjust this percentage value here until I match whatever I'm reading on the machine. If the host machine doesn't really show you a linear belt travel speed, other means of doing it would be a hand tachometer. You can read a hand tachometer on a belt or something that's moving. That would tell us the actual, speed rate of the substrate or the product running through the machine. If a hand tack is not available or there's no speed reference on the host machine, other means we can do is learning a carton length. So that's something our technicians do fairly often. They'll go to the carton product dimension screen. They'll just learn the carton length on a fly. Obviously, they didn't learn on trigger 1 because it's locked. But I can see trigger 2 is 200 millimeters long. Well, what I could do is I can compare what the actual length is. I can compare what the Monet program's learning as the product length versus the actual with a tape measure, and I can make an adjustment to my pulse to inch ratio until my learned trigger length is accurate or matches actual length. Those are just a few means of best practices or best path forward with trying to dial in the encoder speed reference, pulse to length ratio. Okay. The other thing that's important on the calibration menu here with the installer level access would be this encoder A/B transfer to reject trigger distance. So we kind of already touched on, we have trigger 1 is actually assigned to encoder A, the first section of machine, and the first 4 gluing and detection valves. And encoder B is assigned to the second downstream portion of machine for the last 4 gluing and detection valves. So we need to make sure we can allow the system to identify, where trigger 1 is and what speed reference is it using, encoder A or B, and speed in the second speed reference. So we program this value in here. And the best way to program this value here is it's not real critical that we have it perfectly accurate, but what we do need to do is make sure that normally we would measure from the reject trigger, which you guys do not have, just before trigger 2. And that would tell the system that everything beyond, everything 5.1 meters prior to the reject trigger would have encoder B assigned to it, which is where trigger 2 is. And everything upstream or prior to that 5.1 meters from the reject trigger measuring upstream would have encoder A assigned to it. So that's what allows us to have trigger 1 running on encoder 8. I'm sorry. Oh, it's backwards right now, but that's how we can have one trigger assigned to one speed reference and another trigger assigned to another speed reference, and they're not different. So they're showing them both B right now because we tried relearning distance, but I'm using one trigger for both trigger 1 and 2. So basically I got a Y cable. I've got one photo Y and I've got a Y cable. That's why. Yep, that's why. So let's go. There we go. Now that works. That does it. This was B. Yeah, it should be showing A now for trigger 1. So I can see I learned the distance between 1 and 2. So we're showing 1 is 5 meters away from 2. 5.1. So I imagine if I change that to 43356. Calibration. There we go. You can see now trigger 1 has encoder A assigned to it, and trigger 2 has encoder B assigned to it. So what I did is, when I did my learn, I know trigger 1 was 5.08 meters, just over 5 meters between each other. So the distance from trigger 1 to trigger 2 is just over 5 meters. So what I did is in that calibration menu, I put something just lower. I programmed for that A to B transfer distance, something just a little bit lower on what my distance measurement was between 1 and 2. And what that allowed me to do is everything just before trigger 1 is encoder B, and everything before that point has trigger 1 assigned to it. So whatever this distance was here, when I did my master learn, trigger 1 to trigger 2, I just programmed something slightly smaller into the transfer distance, and that automatically put trigger 2 on encoder B, and it kept trigger 1 on encoder A. That's what you're seeing right here. On the calibration menu. So that's why I put in that 5.07, because it was 5.08 was my actual learned distance from trigger 1 to trigger 2. So I just pro 5.08. So I put in 5.07. Now everything just after trigger 2 is using encoder B reference. I'm sorry, everything just after trigger 1, and then everything just before that point would have encoder A assigned to it. As far as the rest of what you get in the system setup menu with the installer level access, it's really that calibration menu is probably what's most critical when it comes to actually the installation and commissioning of the system. There are some features in the install menu. This is where we would program your manager level password. So you can see the 1028 here. So in other words, to program your password in, you would need my password to get to this point. So you need my password to set your password. And our goal is to just program this password in on every system prior to shipping it. So we're going to do our best to make sure this is set up for you prior to the system shipping from our facility. Let's see if there is a one other thing I wanted to show you here. There's a maximum high voltage. Okay. Many of these settings would not really be a lot of benefit for you. But there is a spot where we can set the maximum start end tolerance. There we go right here. So we know for the gluing and detection stations, we can program a start end tolerance. This is where you can program the governor to where, you know, they couldn't exceed this tolerance that we set behind the scenes. They can go up to, but could not exceed it. This was kind of another nicety or important one to know where it's at.